Good morning. I am Indumini Kodikara, Director Export Services from Export Development Board. I warmly welcome the university lecturers, the advisory committee members, students, distinguished guests, and especially today's session speaker, Mrs. Manju Bhargavi from Trimble Solutions, to the webinar on modern software tools used in marine and offshore industry. So this is organized by the Sri Lanka Export Development Board in collaboration with the subcommittee on skills development that is coming under the main advisory committee of marine and offshore services sector. EDB has identified this sector as one of the emerging and potential export service sectors of the country. So as you all know, Sri Lanka is blessed with several competitive advantages to when you compare it with other regional countries, and the strategic location that Sri Lanka is placed and the absence of a marine hub between Dubai and Singapore are some of the key features that we need to develop this sector. Like, in order to earn foreign exchange from this sector, the country needs to prepare with a talent pool to cater to the international demand. So as the apex body to develop and promote exports, EDB expects to increase the skilled professionals and the workforce on this sector, which would help to increase the exports in our country. So I believe that by participating in this webinar, you will gain knowledge on application of the software tools used in this industry. And I encourage you to ask questions during the Q&A session. So thank you, and listen to the webinar. I'm sure it will be great. And I would like to now invite Dr. Sarath Obesekara to address you.
Can you hear me?
Yes.
Yeah. Thank you for inviting me to do the introduction and also continue with continue the program with an explanation why we need to develop this. I'm glad to, and I'm pleased to explain to you why we are spearheading this particular action plan with the help of EDB. And I assume everybody can see my screen. Ladies and gentlemen, girls and boys, if there are any students, I would like to introduce myself again. I have quite a few years of experience in the oil and gas sector in various countries. And I'm back in Sri Lanka, and I became a shipbuilder and a developer for the particular industry, and trying to implement a program to educate the Sri Lankans, politicians and the bureaucrats and also university dons about the importance of this industry. On the left-hand side in the corner picture, you will see a typical jack-up rig, which will consist of a lot of steel structures, process modules, even a helicopter deck and living quarters, everything standing on 3 legs. This is from not very deep sea, but in a certain depth is allowed about 100 meters, I guess. And it can, once it is towed to the sea, can be lifted and use it for drilling and then processing and offloading. Now, EDB has, I'll read a little bit, I think you can see the slide. EDB has taken an initiative to support export sector by establishing an advisory committee, and that is the initiative of the EDB. And I joined that team, and I've been appointed as the chairman of the team. And I managed to entice various other experts in the field from many countries. And now we are trying hard and make every endeavor to educate everybody that this is a very important subject, a very important area to develop. I think the idea of support existing facilities and connect it to lay up of oil rigs and further develop infrastructure in Trincomalee. When you say lay up, I think somebody will explain to you, most of the oil rigs and platforms and floating production, storage and offloading platforms in the areas where there is oil under the seabed. When they finish their contract, they need a resting ground, and they look for areas where there is a calm sea, and they can do the maintenance and upgrading the equipment, even change the crew, and again tow it to maybe even sail sometimes to the location. Some can be in Middle East, it can be in Far East, it can be even the South America, wherever it is. And we are trying to develop that industry, and it is being now done by local companies like Haley's and various other Sri Lankan companies, but they bring them only to do the repairs. And Colombo Dockyard, where I used to be the managing director some time back, we are also doing a lot of ship repair and shipbuilding and supporting this industry in Trincomalee and Ambatata. And our idea is to develop facilities for consultancy companies to carry out design and construction of the oil platforms, modules, and conversion of tankers. You know, very big tankers all over the world are now converted into thing called floating production, storage, and offloading units, rather than building a oil rig from the scratch. That will save a lot of money for them. And then we also want to entice global companies to establish satellite offices and carry out engineering and procurement and construction. In this industry, there's a terminology called EPC, that is engineering, procurement, and construction. There is another management team called PMC, Project Management Consultants. So the students and the Sri Lankans who would like to join or even find employment abroad until our industry develops, you will be joining these companies to work with. It can be engineering and procurement and construction. It can be purely a construction company where you can join and just show them that you have some initial knowledge about it. Then, of course, we are trying to promote bonded warehouses and other storage facilities, which is happening right now. I think one of the big companies in Sri Lanka is already developing a massive warehousing complex somewhere between Colombo and Trincomalee. That is one of the useful locations to store these parts and other things. Capacity building is the area which Dr. Nisanka is entrusted in our subcommittee from Moratu University, who has taken a very keen interest in developing and working very hard to teach the students, undergraduates, postgraduates, about the importance and convey the importance of this industry and develop the curriculum or augment or amend the current curriculum to give some education to these people. Next, please. Okay, I'm not going to read the whole thing, and I might just mention that Sri Lanka marine and offshore engineering industry can be developed in par with global players in shipbuilding and marine engineering and offshore construction. Examples are Dubai and Singapore, and many years back, even Bangladesh, by the, I think, Jamna River, they were only doing scrapping. But they are now moved into even building modules and parts for the platform. So Sri Lanka is still standstill. We have got a massive harbor called Trincomalee. We are proposing to the government and the decision makers that we should use Trincomalee as a nucleus. And since the boom of offshore industry in Scandinavia and UK, where I used to work, and Dr. Kapila, who will do some introduction, is already based there. And a lot of companies from various countries in the continent have their design and consultancy companies. They come to these offices and do the design and project management. And the cost of skilled manpower in those countries going far beyond the payment level what we have. We are talking about more than $100 to $200 per hour, whereas we can, if we can train ourselves, I'm sure we can give a very competitive rate to these people. Next, please. Next one, please. Now, facilities available in the offshore engineering consultancy firms worldwide to establish their branch offices in Sri Lanka. This is where we expect the students who will get keen interest to learn the basics of this and go back to, when you go to an interview, you can say, I have learned this, I have got a basic knowledge. They will prefer to take a person like you than a raw graduate who is just a mechanical or chemical or structural engineer from any university. Of course, we had a specialized education, but some people don't have that. Now, we also have efficient internet, we have office space and new port city. Development in Colombo can be one of the places where they can have their outsourcing centers like in India, in Bombay, Chennai, Vietnam, all over the country, in Asia, they have these offices. Yeah, you can go and sit and work with them and learn. And maybe you travel abroad and come back and give that service to the country or some foreign currency for this country, which is much needed. We have a high computer literacy, and as you know, with this not so fortunate COVID situation has made the Sri Lankans to work more online, and a lot of people started using Zoom and other software facilities to exchange knowledge among each other, though we are geographically very far away. And then some technical people who have worked in Middle East are also coming back, and they can also work with these new students. Next, please. And can you go to the next slide, please? Bhagya. Can you hear me?
Yes, doctor, we can hear you.
Yeah. Immediately change the slide, please.
Bhagya, next slide, please.
Now the existing development in offshore sector in Sri Lanka. I have to give you an insight about what is happening, which you will see bits and pieces in the newspapers. But something which is going on for quite some time, but the government is hell-bent to develop that. That is exploration and production of natural gas, and they become liquefied natural gas in Manang and other basins in Sri Lanka, east and north. Then we are also, I think there's an Indian company which is trying to come to Sri Lanka to develop wind farms. There are already wind farms which are land-based. They are trying to do some offshore wind farming exercise in order to develop green hydrogen, which is a future fuel for the people in the world. Then we have a wave energy development offshore program, which I think one of the, I think Peradeniya University is working hard on that. And the natural gas, which is liquefied at minor 196 or cryogenic temperature, they are stored in tanks, and they want to bring them to harbor through underwater pipelines for the power plants. And we are also talking about building large mother vessels offshore for fishing industry, which can double up with the, to prevent poaching and other things for the defense services. Then we have one or two offshore wind farming or offshore fish farming, which is already taking place in Batticaloa and Trincomalee, which is still not development, but the companies who are doing it doing very well. And finally, of course, we are talking about nautical tourism, where we are trying to develop, like in other countries, like in European countries, in Singapore, having yacht services, yachting and leisure boats and things like this. And we are trying to develop 23 small harbors right around the island. That's other areas. Then again, quickly I'll go through. We have our intention is to develop a curricula for existing universities and training engineering in safety, reliability experts and blue collar expertise in the financial experts as well. And also in the planning sector, we want to teach them generally use planning tools. The courses may come in time to come. Then also we will invite foreign universities to tie up, like some countries do, like in India or even in one of those islands near states. And then we have development of safety reliability study in the universities. Give a little bit more than what you learn and train Sri Lankan and foreign experts even in conducting hazard and operability studies, safety and maintainability. All these things are all related to this high-tech industry of oil and gas. Next. Now, I've just listed some old companies, but there are new more companies which Kapila might even introduce the company which is now going to do a presentation, is also heavily involved in this industry. I have just listed some old companies, but there are some other target consultancy companies who intend to come here. Now, if you have read the newspapers recently, Reserve, a US company, has already started some outsourcing program with IFS. And now they are trying to hire students to train them and work in this industry, what we are talking about. Next, please. Now, I just put an organization chart, how a engineering project management consultant organization chart, which will consist of expertise in various areas, starting with contract administration, quality assurance, quality control, and then you have mechanical structural engineers, and what they do is they do the verification of the designs and drawings done by the engineering and procurement and construction company, and the project management consultant check it and get the approval from the client. This is the basic structure of a oil and gas sector industry. And you can say painting, surface protection in the very salty and corrosive atmosphere, which is a must to learn about it. Cathodic protection, anodic protection, costing, planning, electrical instrumentation, which is very important subject. And also process engineering. What we do is chemical engineering. We want to go a little beyond that and prepare flow diagrams, process and instrumentation diagrams, which is the heart of the design of a platform. Then, of course, safety control engineer, weight control engineer, because they are floating. This is a basic structure. When you learn this industry, when you learn the discipline, expand your knowledge, you can join these sections and expand your knowledge. Next, please. And this is the again similar the relationship with the client, and again same subjects. And you go to the next place. I can share this at a later stage. Is that all? And last one, I would like you to get certain software facilities are currently used. I got this information from various colleagues who work abroad. I'm not going to read everything, but it is process analysis, flare sim, PipeNet, CISA2, CSAM by DMG, SAX by Bentley. These are certain software packages we are using. I think our good lady will explain to you more to just give a insight and background information. And thank you very much, ladies and gentlemen. I will hand over the podium to Dr. Kapila. Thank you very much. Kapila.
Hello, can you hear me?
Yes, you can.
All right. Good morning, everyone. Yes, this is just to spend only 3 minutes, maybe. Explaining the historical relationship I had with Tekla, or a Trimble solution provider. Actually, I contacted them last September, asking some help to introduce the software, three-dimensional model building software. Michael Hodgson is actually technical manager from London office, or he's actually assigned to Finnish base as well. So he actually helped me to communicate with the colleagues, and then he presented about the company way back in 30th of September. Since then, I have had a continuous communication with them. At one stage, they allow me to introduce the software free of charge to students for 1 year if they are willing to use the software. So anyway, so according to our webinar plan, the Trimble said, okay, that's fine. So we could actually initiate offering one of the speakers. So that's where we are right now. I think Manju Bhargavi Thota is actually our main speaker today. She's actually product technology manager from the Indian Trimble Solutions Private Limited in India. And she holds a Master's of Engineering for Structural structural and engineering from College of Engineering from Pune, India. She has more than 20 years of experience on structural and the BIM, that's called Building Information Modeling Software. So she would explain really exactly what it's about. You know that architects, engineers, contractors, supporters, all these people are actually working with building a three-dimensional model. So in the end, if they are not communicative, if they are not actually holding the information together, there may be some disasters in the end. So that I think Mrs. Manju is going to talk about her background and then especially the software that we are really willing to get to know about. Most of the students and or the academia are actually joining today. More than, I see that 41 people joined. So I think I welcome Mrs. Manju Bhargavi Thota to carry on the meeting. Thank you.
Dr. Nisanka, yes, you can introduce.
Thank you, Dr. Saratha Besekera, and Chairman for the Advisory Committee on Marine and Offshore Service Sector, for the very insightful introduction to the marine offshore industry and its future opportunities for Sri Lanka. And again, I would like to thank Dr. Kapila Dirivira for coordinating this webinar with the Trimble Solutions India, as well as the Tekla Solutions. And thank you for giving the introduction to today's speaker. And good morning to everyone, and I would like to welcome you all to the webinar on modern software tools used in the marine and offshore industry. This is a part of the webinar series that organized by the Subcommittee on Skill Development on Marine and Offshore Service Sector under the Export Development Board, Sri Lanka. The aim of this webinar series is to make aware of the opportunities in the marine and offshore service sector and to enhance the skills and capacities of the Sri Lankan workforce to cater for this emerging industry. This workshop today, the workshop today is conducted by Trimble Solution India, and I'm Indrajit Nishanka, a senior lecturer at the University of Moratuwa, and I'll be the moderator for today's session. And this workshop is aimed to provide the knowledge of the modern software tools used in the marine and offshore industry. Especially in today's webinar, our speaker from the Trimble Solutions will provide an introduction to the Tekla structures, which is an advanced structural BIM software for offshore and marine structures. I'm sure the interesting presentations from our speakers will bring about a number of questions. So we would like to answer as many questions as possible, given the time limitations. And you can direct the questions to the sections in the chat. And then our speaker will try to answer all these questions during the dedicated question and answer session. So without further taking more time, I'd like to invite our guest speaker, Ms. Manju Bhargavi Thota, to start the session. Over to you, Ms. Bhargavi Thota.
Thank you, and good morning to all. Students and the lecturers and the organizing committee. We really thank for giving us the opportunity to be a part of your education series and initiative to develop your skill set in the offshore industry, offshore and the marine industry. Moving ahead, let me just share my screen. Hope you're able to see my screen.
Yes.
Yeah. So today we will be speaking more in detail about the Tekla Structures software, which is an advanced structural BIM software. It's not only for offshore. You take any structure as on today. It may be steel, precast, or concrete. So it's a complete structural BIM solution. So when I say structural BIM solution, if I just say about the BIM, so most of you already might be aware of BIM. So BIM is not actually a software. BIM is a concept that we call it as building information modeling. So you may find a lot of 3D models in the market. Okay, so basically any model carrying along with the information when I say an information, it might be the material, it might be the weight, it might be the profile information of that, it might be the overall length. So every unit, whatever we consider, it is with an information. It is loaded with an information. Not only that, this information can be taken to automate your fabrication, and also to the field, we say. So this is how we speak about the building information modeling. In the coming slides, you will know more about this. So I am basically from Trimble, and Trimble is a hardware and software solution provider. So for today's agenda, we'll have a little bit of introduction about our company Trimble and what we are. And then we will see about the design and engineering part. And then, so here, when I say design and engineering, it is process engineering and process design, not the analysis and design. So it's a process design and designing the complete shipbuilding. So you might be interfaced with the different other software apart from the structures. So how you can, with the help of Tekla structures, how this is possible. So that's what we are going to see. And then benefits of BIM modeling. Once my 3D model is developed, how the 3D model can be utilized for the rest of the project life cycle. So that's what we are going to focus on today. And we also have at the end what we offer for students and how you can learn this software. So, so moving ahead. So as I said, I'm from Trimble, and Trimble key things are so positioning, information, and communication. So these are the three, the pillars of Trimble as a company. So when I say we focus on positioning the information, we focus on conveying the information to the complete project stakeholders, and also the communication point of view, and information which is loaded and which can be used for the entire project life cycle. So that's what we speak about, the positioning, information, and communication. As Trimble core is into 5 segments over. So it is into geospatial, it's into transportation, agriculture, construction, and building and construction. And we also are emerging into rail, forestry, water and electrical utilities, and field system management, that is your logistics and planning. So when it comes for geospatial, we are known, and our founder, Charlie Trimble, is the first person who have come up with the total stations, and now it is now available for the rest of the other manufacturers as well. But it was first the Trimble is the first company who has started with this total stations, which is basically taking positioning the layout and everything in the site before you start any of your construction, right? So we are into transportation as well, where we come up with vehicle tracking devices and all. And we are into agriculture. Basically, we come up with we monitor the health of the crop. And construction and building and construction, where the Tekla structure software solution comes in. We also have other products in this particular portfolio, which is SketchUp. We have Quantum, we have Quadri, we have Vico, which is for costing and estimation, and then we have Tekla. So we have a vast product portfolio, and we offer a specific, we want to work together with all the education sectors and want to help to the industry, or help the industry to get a skilled manpower. So we partner with education sectors, and we promote a lot of other, webinars and then the live workshops as well. So when I speak about the construction is hard. So 85% the projects exceed the budget. Okay, they are exceeding the schedule, and so this is because of the downfall of the, let's say, lack of data, lack of talent, and shortfall of manpower. People would like to come up with more sophisticated solutions, and one thing, they want the information at their fingertips to fast the to get the productivity improvement and growth in productivity and all, right? So here, Trimble is helping. It's like a digital transfer. It's helping in the digital transformation, and it has already begun. And as of like after the pandemic, we are seeing like most of them have come up with more, solutions which can automate the procedures and which can work on a remote basis, and also coming up with common data environment, which we call it as CDE. So wherein like information on mobile, desktop, any of the web URLs, people want the information and they don't want to wait for the information. So once they, for those things, they might have to invest some of the some investment is needed, but once you invest that, like they could reduce. They have seen the results, like 30% of reduction in errors. Okay, 10% they have seen the improvement in the completion of the project schedule, increase in productivity, increase in accuracy, not only in the execution, also from the estimation point of view, reduction in rework. So like that, the digital, and if you see here, like the data is, if it's in a digital format, it's easy to access anywhere. And that has proved that it has improved the communication, and it has helped in getting the reduction in the project life cycle. Okay. I'm just running off with a short video about what Tekla structures is all about. So we have seen like different stages of the project and all. Like if you consider mostly like steel fabrication. So in case of steel fabrication, if you see the marine structures, like you find large tubular structures wherein the cost of fabrication, cost of cutting, welding of these elements, and the weld material is also very costly. So accurate estimates in these areas, accurate weld creations, and also accuracy in this weld preparations is very much important. Okay, so for those things, like if I consider steel fabrication workflow, so we first have to detail it, because once we detail, then only we will be able to know the fabrication, the data required for fabrication. As on today, people are still on the 2D basis, but like we have many solutions like CNC machinery, wherein from the 3D model, directly the data can be given to the fabrication or the CNC machinery and all. So detailing fabrication, and then logistic planning, basically lifting of those heavy structures. Okay, so lifting and the erection sequencing of the erection sequencing for those particular structures is very, very important. So when I'm just checking off this particular process, so first process comes as sales and bidding. Then you have, so in the entire project life cycle, if you see sales and bidding and the design, so the design phase is taking around 2% of the project cost. Okay, detailing is taking around 1% of the project cost, but most of the cost of the project is in production, production planning, fabrication, purchasing of material, delivery of the material. Okay, so if you see the major amount of or major cost is into production and purchasing of the material. And if we are not accurate at this particular, and if there is any error during the production and the purchasing of the material, it ends up with a huge cost. So it ends up in huge loss of money. And so in these cases, like, so that's what we say here, like you detail, if you invest some money in detailing point of view, okay, you create a complete 3D model, and exactly if that virtual, whatever the model that we created as a virtual model, so if everything fits in that virtual model, then it will automatically fit at site. And also when you are creating the virtual model, create a model in such a way that it can be used along the downstream process, where it can be, that model information can be used for production, automation, and also the project delivery point of view. So if I am spending a 1% of the cost of the project in detailing an accurate detail, so I can reduce my errors, where my 40% of project cost is there. So at this age, like at the production stage, if there is any rework, there is a huge loss of material, which leads to huge money which is involved, and a loss of money in all these things, right? So that's why. So focus on the detailing, and so that's a value for the model. So once you create the model, you apply the connections, you do the entire detailing, and then you extract the fabrication drawings. So these fabrication drawings are a byproduct of my 3D model. So if there are any variations in my 3D model, I update the 3D model. So my fabrication drawings will be automatically updated. So I want to focus on my model only and reduce the work onto the drawing and the detailing point of view, because none of the today's today's young sector are not interested to do any of the repeated tasks, and they always think about automating the repeated tasks and all. So this is where the solution which will help out. So it will help you to extract the materials, which are, we call it as MTO, material takeoff. So whatever the material that you have used in the 3D model, so that can be used for that material takeoff can help you for procurement of material. It not only the steel material, it is also the any fasteners that you have, bolts and nuts, and also the weld material, which is very, very important in the offshore structures. And you can also plan your fabrication and erection sequences. Based on the erection sequences, you plan your fabrication. Okay. Otherwise, what happens, like if my elements which are to be erected, so suppose say if I'm taking an example of two columns and a beam, and if I'm just getting a beam first in the fabrication in the erection side, and if I don't have the columns which have to be erected first, there is no point, right? So I have to wait until my columns come up. So always plan your erection sequences and accordingly plan your fabrication sequences. Then you track your transportation, stacking, and all of the things. Okay, and in this case of steel, like it's more of automation. So you should have a methodology to link it with your CNC machinery, and at the same time, like this solution, whatever you have developed, should be able to do the connections, and also you can also extract this information and take it to any connection design software. Okay, and when you are doing erecting at the site, you should be able to know whether that particular assembly will be able to be lifted by your cranes, or else where is my location of the crane so that I can utilize my crane optimum utilization of the cranes, right? So this is how the cost of detailing can reduce your like say rework, and also can reduce the project life cycle because all the information is available which is needed. So the focus areas, if you see for the execution of the project, I call it as constructible. So it also means it should be fabricatable or manufacturable, whatever you call. So it should be constructible. So when I say any tool that we are selecting, it should be constructible. So what I mean to say is it should be you should be able to create the 3D models, okay, handle the changes easily. So the solution should be parametric, wherein, so if I change the beam sizes, if I change my column sizes or my tubular sections or my miscellaneous steel like handrails, so today my platform size has to be a little bit changed. So like that, you should be able to, it should be parametric. I just type in whatever the values and then based on that, it should modify. Okay. So, and all my deliverables are byproduct of this 3D model. So I just focus on my 3D model, rest of the things should be automated, right? And it should be collaboration is also key. So as I said, Tekla is a structural BIM solution, and in any project, if you see, like you have a mechanical engineer, you have different disciplines. In that also, like you may have a piping and equipment guy, you may have an electrical guy, you may have a civil guy, you may have a structural guy. So all of them might use a different solution or different software because everyone wants to use a software which is competent or like which competent enough in that particular discipline, right? So, but still you have to work together to execute the project, right? So the platform that you are choosing should be collaborative so that you can interface, you can check your piping and equipment clashes with your structures and all, and then you can come up with the clash-free structure. And then at the same time, because unless I know where the piping and equipment is coming, I cannot place my even structural elements as well. Or if already I have my structural element, then based on that, I have to do my piping and equipment. So like that. So, and also like once I create the 3D model, I should be able to export it to CNC machinery for the fabrication automation. Not only this, okay, is it like, is my process ending over here? No. Till now, like people always speak about BIM or the software. So software is only adopted only in the design officer stage, but we are not taking the information required to the site. So we have whatever the 3D model that we have developed, so that the data from the 3D model can be taken to site for the execution, for laying of the elements at proper locations. And we also have mixed reality, wherein like you can augment your virtual model on the real world and then check. So you have solutions for progress monitoring. So sitting in my design office, I'll be able to see what is going at my site. So status sharing exactly from my fabrication yard, whether my assemblies have been shipped to the site or not, are they erected? So all these information can be processed. So value of the model, in collaboration, you drive the volume and you drive the workflows. And then in the BIM to field in the communication, you say the BIM model has to be taken even to the field level so that it can help you in the execution. So overall, a smooth project workflow is what is expected in the today's world. Okay, so to see about the Tekla solutions, which we say about is a truly constructible solution. We have in the engineering, we have some of the solutions for analysis and design and all, but it is not specific to offshore structures. So detailing and fabrication, as I said, we have steel, concrete, and rebar, so you can take any type of structure. And even for the education, in the construction, as I said, like you can do the logistic planning, you can go with the crane console and all. Okay, and in the education sector, like as I said, like we have Tekla Campus, which is again a free online licensing for all the academic students. And also we come up with education licenses also, which can help the collaboration with the educational institutes and all. So we were speaking about constructible data, constructible 3D model. So in case when you come up with the drawings, in case of drawings, most of the time it's like preliminary drawing, or a conceptual drawing, preliminary drawing, whatever you say. Then you say drawing for approval, then you say good for construction, then as-built drawing. So that are the stages when you consider a 2D drawing. But when you consider a 3D model, so it's like, it is always measured as LOD. So level of development. So based on at what stage we are, so we keep on developing that model as per the requirement. Say at the initial stage, we just create a dumb 3D model, so that we just give an indicative design part. So at that, say we say the structural model, if you see, it's LOD 100 model, wherein it will just have a material and then it just have what a profile it is. Okay, and the basic geometry. So we call it as LOD 100 or 200 models. Okay, once that is done, then when it comes to the detailing stage, then we have a different stages where it's LOD 200, LOD 300. So that's how we measure a 3D model. So BIM model, when you say, okay, any software which is a BIM enabled software, so that software capability is always measured in terms of higher LOD models. So as-built, like LOD 500 is nothing but an as-built model. Exactly what you have, each and every information what you have at site, it's all there in that particular 3D model. So today's world, like people want to go to the digital so that it can be used for O&M, that is for operational and maintenance. So if I have a digital model with me, I can use it for operational maintenance. I need not sit with 100 and 1,000 drawings and identify, or I need not go with a tape to go and measure at site and then check for any retrofittation or any other enhancement or improvement in the existing structures, or retrofitting the existing structures. Okay, so that is what is a Tekla difference. Basically, if you consider a 3D model, it's a truly constructible 3D model which has each and every information with respect to other traditional CAD software. So like material, that profiles, bolts, weld information, then all embeds, then other disciplinary models, then okay, cuts and bends of rebars, that is your reinforcement and all. So form work. So you'll have like complete information once I have my 3D model, which can be used for the entire project life cycle. Okay, So each and every information which is needed. And as I said, you take aluminum, take timber, precast, anything which you name on the structures, and any type of structure which you name. So that is possible to create. It could be bridges, it could be airports, it could be anything. So one single solution for all structural modeling. Okay, in the Tekla products portfolio, we have Tekla structures, we have Tekla structural designer, TEDS, Tekla Power Fab, and Tekla Trimble Connect. So Tekla structures, as I said, is a building information modeling for structures. Then Tekla structural designer is an analysis and design solution, which is purely for buildings. Okay, and Tekla TEDS is for structural calculations. Basically, you will have 2D frame analysis and also connection designs and all of that. And Tekla Power Fab is for production management, that is steel fabrication management solution. And Trimble Connect is basically a common data environment wherein like you can store the project information, you can collaborate, you can communicate with other project stakeholders. So as I said, Tekla structures, when I say the software, it has to be always measured in terms of LOD. So Tekla structures is a software wherein you can create a constructible 3D models up to LOD 500 and all materials and all project types. And it can be used for every phase of the project. It comes with 17 languages and 32 environments. Environments is nothing but 102 country standards. As in, like we have just seen just before my presentation, like you have partnering or like you have consultancies who are working in UK, US, Middle East, India. Like so we have 36, we support 36 country standards. So when you take the software, so it comes with 36 country standards and you can work for any company as a consultant, like any country standards. And okay, so like this, any type of structures, it could be a shipbuilding, it could be your deck or jacket or your platform and all, so any type of structures. So we have so to start with, we'll see Tekla for offshore structures, but what are the different solutions which we have for modeling, then linking with machinery, then robotic welding, then laser scanning, and other tools, like say in case Tekla comes up with an open API. So if you are if you want to get into software development and also enhance some of or automate some of your repeated operations, so using your Tekla API, you can develop your own tools specific to the requirement. Okay, so here, like these examples I was saying, so any sort of platforms that you can, so fixed platforms, okay, a different type of platform tension type, okay. So like this, any sort of platform, and not just simply with the plated elements, you can also have some, not only profile elements, you also have some plates. So a lot of plates might also be involved, and a lot of plates might need to be unfolded or like you have to mold them to get. So you need to know what is the exact raw material which is needed for that, okay. So like this with helipads, then shipbuilding, barges. Okay, again, barges completely with plated structures and all. So you need a solution which can unfold this. Okay, it's not just creating a steel plate around. So you need to have the information which can be fabricatable. Barges, lighthouses, underwater handling installations, which could be material handling structures, silos. Okay. So like that, underwater structures, any sort of hotels or casinos or any such things, floating platforms, like wind turbines, lighthouses, and even some of the concrete structures as well. So Tekla structures basically has a complete component library, which will enable you like we have this type of connections which are in the library. So you can model the elements and then you apply the connections, which come up with welds, welding information, all openings and cuttings, and also unfolding of these structures. Okay, so like this connection libraries you can pick and place from the connection libraries, and then okay, and when you see for the asset the jackets, like where you need some setbacks and also offsets so that it should not clash. So we have tools to model all those things. And then all types of welds, as I said, welding is very important, and also getting the right quantity of weld material is also very important. So all these connection libraries are available. So using these connection libraries, it's very quick and easy to create the 3D model. And you can see the Tekla interface wherein you have steel, concrete together, and you can place steel beams, columns, plates, and also catalog or the material library over here. So this is a user interface of Tekla structures. So, and you can see here how the platforms and this tech helipad and all these are modeled with all the ring connections, ring plates, and different nodes in the offshore structures. Complete and offshore structures is more of completely plated and plated sections. So I can create a clip plane and navigate through the completed model. I'm not getting into details of like how I'll be able to model this and all. It is very simple, like you pick and place, like say from the tool library, I just select a column and then I pick the main part or the, I pick the, I say suppose if I want to place a beam, so I go to a beam and I select what is my profile size. Okay, and again, as I said, like it supports 32 country standards. So from the library, you can pick like whatever the country standard that you are using, you can just select that particular element. And on the right hand side, like you see, these are all the standard section library. So already the CG of it, the root radius of it, the weight. So all this information is already fed. And you can define the material and you pick the first point and second point, the element would be created. Okay. And at any point of time, I just select an inquiry. It gives me the weight of it. It gives me the material length, all this information. Okay. Now I go to a ring plate and then I want to apply. So I'll just select the two beams, and between these two beams, my ring plate connection. So the image may look like only the circular, but this has options which are parameter driven. I just define my parameters, and based on these parameters, I'll be able to create the connections and also the weld details over. Okay, different type of nodes in the offshore structures. The same tool, the same singles tool can help you to apply these nodes at each and every location. And if I want to apply a simple stiffener connection, like I'll be able to select and then create. Okay, so here weld preparations. So based on whether it is a butt weld, bevel weld, or fillet weld, and you need a rat hole for that. So you can define all those. So such a detailed information can be divided. And when you extract the fabrication drawings, all this detailed information is there. So whether it is a field weld, what is the size of the weld? Okay, and if I just select any particular assembly and I say shown is selected, it shows me where are all the welds available and where my secondary parts are coming. So how my shop drawing will look like, or like how my particular assembly will look like, or element will look like after my weld preparations and the fabrication. So not only this, I have solutions for modeling the handles and all. So I define the profiles and handles, and I pick first point and second point. I'll be able to create the handles. So in a similar way, I have sheep ladders, then I have staircases, So I just pick first point and second point, then my staircase will be created with whatever all the, so like this, all different nodes. I have a model wherein I have just created all the connections just to show you like what are all the different connections and what the library I have for this. So, and how the weld preparations and all can be defined, and different other connection nodes and all, so which can be applied and created. So once I create, then I extract the fabrication drawings out of it. So like this, it may be your platform, it may be your saddle, and also in case if you see, especially the round pipes and all, like it's very difficult to come up with the fabrication for those. And different sizes of jacket legs, wherein you have a different profiles. So reshaping of this profiles, it's a single solution which can help you to model that jacket legs, stiffener connections, splice connections. And here, these are the information, the type of weld and all if you define. So this information will be automatically taken to weld preparation machines and CNC machinery for cutting and for weld preparations and cutting of these tubular sections. And they can also extract the report with the weld material. Okay, so once I create the model with the structural model, I can use it for my plant integration. Like, so you can see Aviva, you can see Intergraph, you can see Catmatic. So these are some of the, and also Tekla Structures is open to, it's an open BIM solution. So it can take in STEP, IGS, different file formats like DWG, DGN, SDNF, XML, IFC, CIS2. So like these different file formats. So once these file formats, you can have an interface. You can also, we have interface with SACS, which is again, analysis and design solution. So once you have created a model in SAC, and then you can import that model into Tekla Structures and you can further take it to detailing. So what we are doing is from the design stage, we are able to take the input. So we are not creating again from scratch. So we are keeping on adding the data, and then we are reusing the information. So in this cases, what happens, the transfer, there will not be any chances of missing of any information or anything, right? So like this, we have, so wherein you can do your piping and equipment in any solution, and then attach it as an interface to run the clash checks and all. So Catmatic, this smart, Intergraph, and then Aviva. So all of these, you can, IFC is IFC, the full form is Industrial Foundation Class. So here, if I take DWG or a 2D, for the 2D formats, DWG and DXF are the common file formats which are accepted widely. In the similar way, when you want to exchange the data in 3D file format, IFC is a file format which has to be commonly used. Okay, so any solution or any software which you are able to come up with an IFC, so that is a common platform now to exchange the data in a 3D file format. Okay, so if you go in detail with the Tekla Structures and E3D, that is Aviva solution. So in Aviva solution, so what we can do is, say Tekla Structures. So I can use Tekla Structures because Tekla is good at the structural point of view. So I can create the model in Tekla Structures. Then I can export that model to my piping. I can either attach my piping and equipment as a reference within Tekla Structures. I can rotate, I can navigate and see, I can run class checks where my equipment is exactly coming up. So based on that, I can plan my equipment, foundation, pipes, piping and pipe supports and all. So all these are like, I can attach it as a reference so that it will not load up my model or increase the file size or anything. So these are all references. Now this is I'm with purely structure point of view. So like this, I can come up with a complete model, create the model. Then I can export these solutions to Aviva. So when I come back, so when I import this from Tekla, I can import it to Aviva. So just select and import. So it comes up with different mapping files and all, because the name nomenclature in Tekla, nomenclature in other solution might be different, but we have come up with a mapping. So first time import, it just imports, and second time it shows you what are the changes. So like this, I can import, and then I can also like say once I import in back in Aviva, and then I check with the equipment or piping, and in case if there are any changes, if that file is changed, so I can import the revised model back to the back to Tekla structures, check what are the changes, and then I update those changes. Okay, so like this, instead of doing the change communication and everything using 2D sketches or 2D drawings, so directly exchange the model, and it also shows you what are the changes, what are the variations, and then you can get, go through immediately. Okay, so you can also, the final model with complete disciplines, you can run a class check and see. So like this is my Tekla structures model. Then I am attaching the interface of my piping and equipment to my Tekla structures model, so that my complete offshore structure is ready and I can use it for class checking and all. So if there are any changes, I can. So this is how like I can come up with the reference models. I can navigate along with my piping and reference. So that's what I'm saying. What you see is what you get. So here, if that fits here in the virtual model, that means it also fits at site. I'm not getting in detail like how to model and all, because it's very simple. Just select the it's a menu driven. So simply select and then place. It's very easy to learn software. And so I can, at any point of time, I can switch off my other discipline models and purely work on Tekla structures only. And then suppose say from this here, again, I want to go with civil. That is only my platform, this footings, then cable trenches and all. So I can filter out. So you see here is a single solution, as I said, like which is enabling you steel and concrete together, where you can do the reinforcement detailing, you can do steel fabrication and all. So all other things. So you can extract the drawings out of it. Just simply select that and extract the drawing out of it. So your drawing will be ready. And if there are any changes, you just update the model. My drawing is a byproduct of that. I need not sit and draw anything, any single line over here. From the model, it is converting into the 2D. And if required text and all can be customized or automated. Okay, so as I said, all type of reports along with barcoding and all can be extracted. All type of fabrication drawings can be extracted along with the welding preparations, welding information. So some of the GA drawings or the general arrangement drawings, which we call. Then some examples of your detailed drawings. Some more examples of platform. Side elevations, detailed connections along with the weld details. These are all completely automated along with my weld and annotations and all are coming automated. So then it's a it's an error-free information, because as I'm saying, you just check the model, my drawings and all the weld preparations, annotations and all are automated in my drawing. Okay, so like this, each and every blow up use the jacket, this leg connection details for the jacket. So like this, all the information can be extracted, barcodings, and drawings are not just only for fabrication or the arrangement. You can also extract the drawings for your erection sequencing as well. So what has to be erected first? What has to be erected next? Then next, means because these are all normally welded near to the shore and then they will be transported. So like this, based on the different erection sequence, you can start erecting it. Okay, and then how it has to be lifted. So all these simulations can be done, and then from where it has to be lifted, where your crane location has to be placed. So all this planning can be done before, so that you need not do again at site replanning all your things. So most of the things would be like planned well before. When you plan well before, then the surprises at the site are less. So like this I can. So once my 3D model is done, we have seen how to integrate with other disciplines, how to extract the required deliverables like drawings, and then the like material takeoff. Then it can be exported to CNC machinery. So the model, whatever we have done, so directly we can export the data to CNC machinery. And when you open to the CNC machinery, then you can see like now you need not sit in the fabrication shop with the chalk and the drawing. So already it scribes on the main part, like where my secondary elements have to be welded and which part has to be welded. So it scribes. So it's very easy at the fabrication shop, and there is no chances of errors at the fabrication shop. Okay, so like this. Once the CNC file, if I'm importing, and I'll be able to view before it starts cutting, before it start drilling, and before it start welding, where exactly my secondary members are coming, and which are all the parts which have to be welded to this particular assembly. And also input to the plate optimization, because I have a lot of plates which have to be cut. So I have to arrange the plates in such a way so that I minimize my material, wastage of my material. So from my entire model, all the plates which are required, I just extract, and then I input to this steel projects, or input to a software, like wherein it does an optimization for me. It tries to nest the plates, arrange the plates in such a way so that it comes out with a minimum wastage. You see, steel is very costly actually. So optimizing of this material is very important. And not only for the plates, even if I have profiles, we call it as bar nesting. Suppose say if I have 6 meters length of a profile, and in my model, somewhere I have used 3 meters, somewhere might have used 4 meters, somewhere I might have 6 meters. So like that, it tries to combine the lengths in such a way that I end up with a minimum wastage. Okay, so like this, it can automate, and if you have an automated fabrication yard, so it can still more optimize your material, optimize your production. So like this, from the offshore structure, you may have different type of connections which are coming up. And based on that different type of connections, the plate or the profile has to be cut. Especially the pipes, cutting of the pipes is very difficult, and cutting it with error-free manually is very difficult. So you can export this information along with the weld and weld preparation information to HGG machines that are very specific for the tubular structures. Okay, and then you can extract. So like this, for these tubular structures, so you can export the data to HGG machines so that it does a clear cut of this particular pipes, and it can be used directly for welding. So as it is automated and it's with the CNC machinery, like the accuracy is well maintained, and also the speed of or like the productivity also is very much improved. So these type of cutting, profile cuttings. And also we have seen in the earlier video, like this information, the CNC machinery is just not only for cutting and drilling, it can also be used for welding automation. So we have welding robotic, so you can robotic machines, so wherein it automatically, I just feed in the assembly, so it picks up the respective parts and the type of weld which I have defined. So based on that weld types, it automatically welds. So much of fabrication automation can be done. Okay, so as I said, weld reports can be extracted and the exact weld quantity can be extracted. And once the fabrication is done, so you also want the data to be taken to the site. So if you want to take the data to site or to the total stations, we also have integration like wherein from the model, so you can pick up some of the points which you want to take it to the site or the layout machinery. And then from the 3D model, you export the data to layout points, and that data can overlay at the site, and then you'll be able to see. So it also accepts 2D drawings and it also accepts 3D models as well. And say in case if you are planning any existing structure, you don't have drawings or you don't have as-built drawings or anything. So in that case, like if you, and suppose in case if you don't have if you don't have drawings and all, so physically going and measuring and creating a 3D model for it, or like if you are planning any maintenance activities for that, it's very difficult to each time to deploy a person at site and then measure all this. So we have laser scanning devices which can be used for accurate laying of the model at site. This is because the LM880 machine which I have shown you, that is just simply a DWG and DXF. But these laser scanning devices that of Trimble can also take in the complete IFC model or the 3D model, and then that model-based laying out can be possible. Okay, and laser scanning devices is just not only for as-built verification and all, but like in case if you have any old structure, so you can scan that. So it can scan the complete data in a point cloud format, and then you can import that into the virtual model and then cross-check, which can be whether all the assemblies are as per the virtual model or not, or existing, if you want to create a model of the existing structure. So you scan the data and then you import it so that you know what is the existing structure, and then from there you can plan your retrofittation or the expansion of that particular We can also place a model in Google Earth. And once the model is developed, as I said, like the information is at your fingertips. So you can also export the this information, the common data environment, which is Trimble Connect. So in the Trimble Connect, like once you upload the model to Trimble Connect, the models and the drawings, so you will be able to view this information in your mobiles, on your desktops, iPads. Without the Tekla installation, you will be able to view all this information. And this information means just not only a 3D model, you can also create walkthroughs, and then you can also see what's the weight. It comes along with the attributes. So what's the weight of it? What's the volume, center of gravity, erection sequencing. So all this information can be seen. And last but not the least, like it also, Tekla is, as I said, an open API. Tekla has an open API functionality, which is like, if you are aware of .NET API and all, like you can interface with Tekla structures. So it can help you to link with ERP. It can help you to create your own component library, then interface with like layout systems and all. So all these things, so you yourself can develop your own applications. Okay. So these are some of the tools, like say parametric models, then linking with the layout machinery and all. So this has been done using the .NET API. So you can also take up as your projects in your short-term or the long-term projects in your third or fourth semesters or something, and then you can, you can work on these as a project, and then you can develop some of the components with the interface, or like automation with the robotic machines and all, robotic welding technologies and all. So we can help you out with this, with such type of projects as well. Okay. Some of the offshore reference projects. These are all prediction platforms actually in India, like Hazira, L&T Waldale, like Saipem, NPCC. That Middle East and India, the NPCC is the company who works on offshore structures. Cameron is who works for overseas projects and all. So a lot of companies are there. So this is structured Indonesia, Middle East. So platform structure in China. It's a jacket structure, different jackets. Again, this is MPCC model and the type of connections. So NPCC has worked with Open API and then have automated some of the components here. If you see these nodes, and also they have developed some components which can help in modeling, quick modeling and all. And before I end this, so the session is open for questions and all. So what is for students, like as Mr. Kapla has already mentioned, that we are partnering with, or like we are along with education institutes to promote the solutions so that you can come up with the required skills to the industry. So Tekla for education, if you see, like you can go to downloads.tekla.com, and once you go to downloads.tekla.com, so here these are the 4 steps. Like you can say you can register with your email ID, any of your email IDs. Okay, with your personal email IDs, you have to activate the Tekla online licenses, and then you download the software. It shows you the complete information, like which version, which country standard that you want to work. And if you need any extensions, you can download these extensions. Also, it can take you to the Tekla webinar pages, which come with a lot many training sessions and skill sessions. Okay, so here you can learn more. So as I said, like Tekla is coming up with different other products also. So you have a startup, troubleshooting, guide, videos, first steps with Tekla structures. So this will all help you to learn the software. We also conduct competitions for all the students, wherein like global level competitions also we conduct, so which will enable the students to get exposure to the exposure globally, and also identify the job opportunities in the industry. So basically, to summarize, the benefits of the BIM model, exactly what you see is what you get. So whatever is your virtual model looks like, that's how you are able to execute at the site. So there will not be any costly surprises at the site. And if the model is accurate, the execution is smooth even at the site and also into the fabrication shop. All the drawings and all other reports, material takeoff, and all are deliverables of the model, byproduct of the model. So that's why if my model is accurate, so all my deliverables are accurate, and at the same time, if any update or any changes are there, as I have a parametric library which will enable me to do the changes easier and faster, so my all other deliverables also will be automatically updated. And value of model to all the project stakeholders and with all different disciplines at each and every stage of the project, you can exchange the information which help you to collaborate well and reduce the RFIs, request for information at site or at the planning stage, especially in the fabrication shop, at the basic engineering level, fabrication and direction phase. Integration with CNC machinery improves the productivity, and the given BIM to field data will also improve the speed and accuracy for the project execution. Right. So the session is open for questions, and in case if you have any questions, I'm ready to answer. That's all from my end today. So the session is open for questions. If you have any questions, please let me
know. This is Dr. I have a question. Hello.
Hello.
Yeah. Dr. Nisanka, is it okay? Questions, right?
Yes, please.
Okay, great. Thanks, Manju. It was an excellent summary of the tools and presentations and everything covered up properly. And I have a couple of questions. One of the slides you described about the constructible, collaboration, and communicate. There are three conceptual integration patterns to the model. You say constructible, the value of model, and then you actually say collaboration, so dry volumes. That means you actually put all the information into the model to sort of like a static model you generate, and then integrate the information into the model, so partly static or dynamic type, and then you actually bring the BIM model to the field. So I see that in the oil and gas industry, we do a lot of three-dimensional modeling with the static information coming from wells and the seismic. And the same concept you use here. So when we create a static model and then apply the fluid parameters into the model, that the model becomes a what we call dynamic model. So in your case, BIM to field, there's still a static model, right? Because you are not actually implementing any dynamic variation into the model. Thereby, you need to do reintegration back to the model and then get back to the iterative manner to develop the model. Am I correct?
Yeah, it's a statical, it's virtual model, yes. It's a static model. Yeah, it's a static.
Static models are usually simple parameters you actually implement from the design, maybe architectural design. And then you put the environment.
So we call it as static, or we call it as virtual models basically. Okay. The detailed virtual model will be taken to the site, and like it will help you to position at site, and at the same time, like whatever the real world model, means already executed model, like you can capture the locations of that, and then you can import back to the virtual model to cross check whether there are any variations from your design model.
Okay. Question number two, like Sri Lanka still do not have steel manufacturers into a certain caliber that probably you have in India or maybe in China and the other places in the world. So the way that you create the BIM model, So you have the software. So you actually shown one slide where the manufacturer could use to optimize the technology to minimize the wastage. So how is the, if the manufacturer is in another country where they use a certain robotic software pattern, which is not compliance with the Tekla model, how do they incorporate your design BIM model to their manufacturing software tools?
Okay, so we have two solutions over here. One is the NC file format, which is commonly accepted by almost all the CNC machinery, almost all the CNC machinery. And in case, if any of the companies are not with there's such type of automated technology, we also come up with an DXF file format. DXF means the fabrication data, whatever is needed, we are converting that to a DXF file. And that DXF file can be imported into those cutting those optimization machines, and it can help you, because DXF is a must, and it is a minimum requirement at any fabrication yard. Okay.
Okay.
So from the Tekla structures, we can also expense. We enable even a DXF file format, so which is accepted. It's 100% accepted anywhere.
Okay.
And when you are saying that the fabricated is at a different location, so I also have mentioned about like the common data environment, that is Trimble Connect. So you export the data to the Trimble Connect. So without the person having the software, so he will be able to view all the data, because our URL will enable the person to view the file in a 3D format. And also, like, you can update, you can upload those drawings and everything. So instead of sending through emails, you can send that particular, give an access to the person to that particular common data environment. If I have to just showcase that, one second. So we have here connect.trimble.com, and so this is a common data environment file for common data environment, irrespective of the software installation. You can view the data on mobile or on iPad or any of the web URL. And there are free CNC viewers, machineries and all. So from there, so this is how, like, without having any of the installation and all, the person will be able to view all the details. And this is just not only the 3D model, he can also view all the 2D drawings as well. Just simply, you invite them to this particular project with the email ID, and the person will be able to view. One second. Yeah, you're able to see. So this is my model information. Okay, and anywhere he just picks. So you get, 1 second, I have to. This is, yeah. It's not many windows. Okay, so you go and just select any of the element over here, and then you see the complete object information at the side, like what type of element it is, So here you get the material, you get the weight, you get all these things. But apart from this, if you go back here, you get the drawing of this. I mean, and for any element, like you'll be able to get the drawing. And not only this, like all the exports as a DXF file format, as I said, DXF is a common file format which is acceptable anywhere. So this can be exported to a DXF file format, which will enable you to do that bar nesting or the plate nesting. And also, not only this, like if I have to speak on like for profiles, basically there are a lot many Excel sheets or like a lot many applications using Excel sheet. You can do this bar optimization as well. And or using API, again, as I said, like we have an open API. So based on what solutions that company is having or that client is having, so based on that, people can develop their own applications using our open API solution. Means they can develop their own interface with the with any software, which is again open API enabled.
So does that mean Tekla can download the model in terms of disintegrated components like the models and nuts and bolts and pieces and their specifications separately for the manufacturer to upload that to their applications, right?
Yeah.
Okay. So that helps basically
Yes.
sort of like compatible way of getting the
Yeah.
bits and pieces together.
Yes.
Yeah, thank you, Dr. Kapila, for asking those questions. And again, thank you, Ms. Bhargavi Thota, for a very informative session on these Tekla solution software packages. And we have one question from the audience. Ms. Preeni Vittanage has asked, like, hope this solution provides testing for the testing of the model for adverse environmental conditions.
Okay, actually, to be clear, it's a building information modeling solution. Okay, so you can export this data to any analysis and design software which can do those environmental testings and all. So this is not for testing, but this can give you, I mean, the information from here can be extracted and it can be an input for your other solutions where you can do the testing based on the environment.
Right. Yeah, thank you. Actually, I have one question. So what are the computer system or hardware requirement to use this software in our personal computers or?
Yeah, minimum 16 GB RAM is needed. Okay, and OpenGL hardware. And if you go to our website, tekla.com, and then if you go to the user assistance, so there you will get the complete information, or I can send to Indumini or someone. It's available, and I can share you the complete information on the hardware recommendations of the system. Okay.
Right. So one of the questions I have is in today's webinar, mainly we were focusing on academics and research students and some of the working engineers.
Mm-hmm.
And so you said that you can have a kind of a collaborations with educational institutions and as a software solution that you can provide them with software assistance and things like that. So how, if any educational institution want to like collaborate with you to introduce this software?
Yeah, we provide education licenses to all the institutes with very nominal charges. It's around, we call it as Trimble Technology Lab.
Mm-hmm.
So it's just not only Tekla structures, whatever all the Trimble product portfolio that we have, like we have SketchUp, we have Tekla Structural Designer, and also In some cases, we also have our hardware equipment as well. So, but when our hardware equipment comes into picture, then the software is given free of charge, but the other hardware and all has to be purchased. Okay, so hardware solutions will be provided with an educational licenses for so it is on a yearly basis actually. So every year you need to renew it.
Right.
And some very nominal charges are there for that. So separate educational version will be given. And which is again, there is no limitations on that particular solution. It's only like you'll get a watermark that it's an educational version.
Right.
And like in case some sort of workshops are needed or any training sessions are needed. So this all we provide in detail to the students as well to help all the educational institutes or to develop the skill set for the students well.
Right. Yeah, that would be really helpful for our students.
Yeah.
Any other questions from the audience or from any panel members?
And also to encourage the students, as I said, we also do global competitions.
Oh, okay.
Okay, all for only that is student level entries only.
Mm-hmm.
Dr. Nishanka, I have a question to.
Yes, Dr. Obesekar.
Indrajit, sorry.
Yes, Dr. Obesekar, go ahead and ask the question.
Now, the way I feel is that universities and educational institutions who would like to explore the possibility to get into offshore industry need training education among the graduates or basic education how to use this software. Now, ma'am, where do you provide such collaboration with educational institutions in India? Any particular university where you have had a collaboration, which is subsequent to the question raised by Dr. Indra?
Yes, sir. We have like IIT Madras, where we have set up the Trimble Technology Labs. We have IIT Roorkee, okay, and a lot many Tekla authorized training centers as well. So around, we can share with you like around 5 to 6 IIT colleges where we have set up the Trimble Technology Lab. I'm saying not only Tekla structures, like the complete Trimble Technology Lab, which is one of the good references is IIT Kharagpur and this IIT Roorkee and IIT Madras. Some of the examples.
Dr. Nishanka is a good idea to explore.
And a few other engineering colleges are also there, sir.
Okay. Then I also
if you want, like we can share the list of all the institutes like where educational version has been given or like they're using, where we all have implemented, and some of the programs that we have done at those institutes like IIT Madras, like we had again through 3 days of workshop showing them all the latest technology, and also helping them with their hands-on, like how to use the software, and also such type of training sessions were also done. And as I said, competitions have been held. And if you see L&T, again, L&T had they had their own BIM Academy, wherein we have provided the complete educational licenses for them, and they are doing the internal training over there. First, the trainer program has been done, wherein some of their senior most employees were trained on their technology, and then later on they are training their internal team members. Okay, and also like IIT Madras, as I said, colleges we have directly we had done workshops to the students, and also the military engineering services, where we had conducted workshops and sessions to the faculty over there.
Thank you. And you are covering most.
I think our website also has those information. Like if you go to tekla.com, I think our website has the information on the universities where we had done the tie-up and all. And also, so like we had before the pandemic, we had also done one session at Nepal as well, wherein purely for the education segment in Nepal.
Okay. Now, another question is, this is mainly on structural side, I assume. What about the process engineering side, pipe layout, stress analysis?
Yeah, like if you take the pipe layout and all, like you can take E3D or Aviva E3D, wherein like you do the complete pipe layout and everything in E3D. We have a direct, that's what I said in my first slide, collaboration is the key. So wherein, because if you see the Aviva E3D, it's more of a complete plan design or like complete layout design. So that can do a high level layout design, but that cannot drill down to the information required for erection and fabrication point of view. Okay, so what we are saying is like use a tool in such a way that it can interface, which is the information with your layout design, and also with your piping and with the fabrication point of view. As on today, you see any of these EPC companies, like you take the name of Technip, Technimont ICV, then you take ThyssenKrupp, Linde, and Saipem again in offshore, NPCC in offshore. So all these companies use Tekla for the structures point of view. Okay, they take this structural model to E3D, where they collaborate the piping and equipment in E3D. And then this model, once the collaboration is done, then the model is used for the structural drawing, detailing, and fabrication point of view.
Finally, idea of promoting these educational aspects in Sri Lanka is also to entice companies like yours to establish a satellite lab or a station in Colombo in the port city. You have in India, hopefully you have in some other countries as well. Is there any chance or possibility that you establish an office here with all the facilities, with few staff, so that people have the access to that?
Yes, sir. Like we have a reseller in Sri Lanka who is taking care of all these. It's a Tekla authorized reseller. Like
Who is that?
Get back to you, sir. I'll get back with the details.
Thank you.
Mr. Datta will get back to you with the details, because I'm from the technical team. I have a person who takes care of these operations in Sri Lanka. Okay, he will come up with you on the information about that, on who is a service provider in Sri Lanka who can help you out with these all initiatives.
Thank you. Any other queries from the students who are listening to this, please, Dr. Nisanka?
Yeah, so if the attendees have any other queries, you can put them into the question and answer session given below. So please ask if you have any questions. And also the panel members, if you have any questions.
I think one more thing from me, Kapila here.
Yes, Dr.
I thought maybe Katubado Peradenia, because I remember Mr. Dutta from Trimble company informed me that he has been to Sri Lanka, University of Peradeniya and Katubad 2 years back. Most probably they must have introduced the tool to the universities. but I'm not aware of exactly the status as of today. But with Trimble India, Trimble Solutions of India, we will get back to communication again, and then probably Kattupatha University and the Peradeniya can be a sort of like a satellite laboratories for students to train, and can have actually very direct communication with the students, I guess, in the future. So I think Dr. Nisanka and EDB probably communicate with Trimble Solutions India to get that link updated properly. Thank you.
Thank you, Dr. Kapil. So with that, I think we can end our webinar for today. So first, on behalf of the Export Development Board, Subcommittee for Skill Development in Marine and Offshore Sector, I'd like to thank Ms. Manju Bhargavi Thota for giving this very informative session on Tekla solutions and the software packages. And also, I'd like to thank all our participants for showing their interest in marine and offshore service sector in Sri Lanka. And your participation is highly appreciated. And we hope to see you all in the future webinars as well. So to officially conclude the webinar today, I'd like to invite Ms. Priyadarshini from Export Development Board, Sri Lanka, to do the vote of thanks.
Thank you, Dr. Nisanka. So good morning, everyone. I'm honored to have the opportunity to give the vote of thanks at the end of this successful event. First of all, on behalf of the EDB, I take this opportunity to thank the chairman and other members of the subcommittee on skills development of the marine and offshore services sector who took the initiative to organize this webinar. Especially our gratitude goes to Dr. Kapil Ediriveera. Also, my special thanks go to our speaker, Ms. Manju Bhargavi, for taking your time of your busy schedule to contribute to the webinar. I believe this webinar gave all the participants a good knowledge on applications of Tekla software solution services. I must not forget to thank the volunteers of the Subcommittee on Skills Development and the EDB team who contributed to the success of this webinar until the last moment. Last but not least, I thank the academics, graduates, undergraduates, postgraduates, and other enthusiastic in this marine and offshore services sector for participating in this webinar. Without you, this would not be a success. Thank you and have a pleasant weekend.
Thank you.
Thank you.